Hey everyone, welcome to the third video of the Near Basics batch, part of OWS Education, created by the OWS team. In this video, we will look into how Near's thresholded proof-of-stake algorithm works and how it overcomes the decentralization part of the Blockchain Trilemma. Let's dive in. So, proof-of-stake is the chosen consensus protocol on Near that enables validator nodes to reach consensus about transactions. Check out our video on proof of stake below if you want to know how this family of algorithms work. More specifically, Near uses a thresholded proof of stake election mechanism to randomly select its validator nodes. Let's run through how the TPoS selection process works. So, the selection process for validator nodes on the Near network happens once every 12-hour epoch. For each epoch of time, 1.4 million seats must be allocated to a set of validator nodes, which on Near are called witnesses. Seats give witnesses various responsibilities, some of which are to process transactions, create and sign blocks. The TPoS algorithm is responsible for pseudo-randomly computing the selection of witnesses. Essentially, every 12 hours, the protocol reshuffles the network's witnesses, randomly selecting new ones. So, how are the witnesses actually selected? Nodes that want to be selected as witnesses for a particular epoch will submit a special transaction called stake action, indicating an amount of tokens staked, locking that amount in the transaction for 3 days. Based on the set of all special transactions submitted during that epoch, the TPoS algorithm will then determine the minimum threshold of stake tokens needed to become a witness for the following epoch. All nodes that are above the threshold will be selected as a witness, and some number of seats out of the 1.4 million of them relative to their staked amount will be allocated to the witnesses. Check out nearexplorer.org to see how many witnesses or validator nodes are currently validating the Near network. What do witnesses actually do? Well, once the witnesses are selected, they will be responsible for verifying transactions and signing blocks for the following epoch, receiving block rewards and transaction fees as compensation for their contribution to the network. So let's talk about how decentralization and security work in TPoS. About decentralization, because the reward for validating blocks is proportional to the stake, meaning that two accounts with 10 tokens each earn the same rewards as one account with 20 tokens staked, there is no incentive to pool computational resources or stake, so the decentralization of validator nodes is maintained. The network also does not require nodes to have performance hardware to run as validator nodes, maintaining low barriers to entry and therefore maintaining decentralization. About security, to rewrite a block or perform a long-range attack, a malicious actor must know the private keys of the witnesses that hold at least 2/3 of the stake for the previous 2 epochs. The probability of this happening is negligible, rendering the TPoS algorithm highly secure. So in the video, we discussed how TPoS is used by the Near network to select validator nodes. We also briefly explained how TPoS ensures that the consensus process is decentralized and secure. In the next video, we'll look into how the Near network uses Nightshade as a sharding mechanism to process and store transactions at scale. Thank you and see you then.